Answers to the quiz. So first thing I need to do is I need to identify whether this is ionic or covalent. And the easiest way in Science 10, because we're going to keep it fairly straightforward, is to look at the first element and say, is it a metal or not? Is it on the left side of the periodic table? Is it on the right side of the periodic table? Or another way to tell is, if you look at the charge on the periodic table, is it positive? That's a metal. Is it negative? That's not a metal. So when I look at my periodic table, I see that this is sodium. It's on the left side. So in my mind, or even on my piece of paper, I might make a little note and say it's ionic. That means the ionic rules for naming are going to apply. The second thing I need to check is sodium multivalent? And that's the fancy way, Ty, for saying, is there more than one charge on sodium? Is there? Say no. No. So that means the naming is about as easy as it gets, and I'm not saying it's easy. It's about as easy as it gets. It's still tricky, but it's going to be sodium. I don't need to put Roman numerals after it because it's not multivalent. And I'm not going to say chlorine. What am I going to say instead? Chloride. Half mark for the sodium, half mark for the chloride. Yes? What did you put for a Roman numeral? I'm going to take a half mark off. Yeah, I got to take a half mark off. Sorry. But you won't do it on the test when it counts, so that's a good half mark to lose. Calcium bromide. Okay. First thing I need to find out is Ca a metal or not. Is this ionic or covalent? It is ionic. Calcium, is it multivalent or not? So I'm going to use the crisscross rule. I'm going to do my rough work right in this area, and I'll do my final answer in a row over on the left-hand side. What I do is I go to my periodic table, I write down Ca, and as a pretend exponent, I write down its charge. What is calcium? What's the charge on calcium? 2. Then I also write down bromine, bromide. What's the charge on bromine from my periodic table? -1, but I'm just going to say 1. Give me 1 second here. Right-click, pause. Okay. Now what? Here. Crisscross. On the test, if you make the chopping noises, you're going to tick off your friends. But in your homework or at home or in your bedroom when you want to do here, go ahead. It helps. So it's going to be, come on, pen. Come on, pen. The Ca is going to have an invisible 1 on it. Am I going to write the invisible 1? No. And the Br is going to have a 2. But by the way, the crisscross rule, it works great when there's only 2 atoms. In Chem 11 and Chem 12, you'll learn a more generalized approach because, hey, what if there's 3 atoms? You can't really crisscross because is there like a zigzag? It gets more complicated. But for now in Science 10, this will get you through it. Someone had a question? Yes?
What if I forgot to put the 2? Is that okay?
Forgot to put the 2, half mark off. Okay. FeCl2, ionic or covalent? Ionic, because it starts with a metal. Now, is iron multivalent? It is. That one I have memorized. I know it is. So it's going to be iron and some Roman numeral, and then chloride. What Roman numeral? How can I figure it out? Well, I can uncrisscross. I can say, you know what? This must have come from a little 2 there and a 1 there. Oh, what must the charge have been on the iron for this to work when I uncrisscross? When I which is the opposite of here. Okay. Half mark off if you missed the Roman numeral. Half mark off if you missed the "ide." 1 mark off if you left it blank. I think that's obvious. Okay. Copper 1 sulfide. How can I glance at this and right away know it's ionic? Yeah? Roman numeral. Yep. Because we don't use Roman numerals for covalent. So I'll make a little note still. Ionic. Oh, and they gave me the charge in the name. Great. So I know it's going to be, when I show my rough work, copper is not CO. What's copper?
TV.
Oh yeah, for some strange reason. The charge on copper was 1. Sulfide, that's sulfur. What's the charge on sulfur? 2 or 3? 2? Crisscross, the actual formula would have been Cu2S. Am I going to write the 1, Leah? No. Cu2S. Half mark for the Cu2, half mark for the S. If you're missing the 2, half mark off. Yes. There's some kind of joke to be made there, but we'll leave it alone. And then you're going to put the watch away or whatever the heck that is, Josh? Thank you. Okay, Curtis, less distracting, more learning. Boy, getting lots of interruptions here. The next one. Oh, hey. Kenzie, the fact that I have this thing here in brackets, this is going to be a polyatomic ion. This is one of the ones from the back of the pink sheet. I'm going to have to go hunting it. Calcium, Ca, it's ionic. Does calcium have more than one valence, more than one charge? No? Oh, great. So I don't need no Roman numerals. So I'm just going to write for my answer calcium. What is OH? Hydroxide. Hydroxide. Half mark for the calcium, half mark for the hydroxide. Potassium permanganate. Say what? Okay. Ionic or covalent? Potassium is a metal. It's ionic. I'm going to crisscross. So I know potassium. That one I do have memorized. It's got a charge of 1. I have no idea what permanganate is. MnO4, and I'll put it in brackets because I'm treating it like it's one weird element. So I'm going to write a little MnO4. What's the charge on it? 1. Oh! When I crisscross, this one already works. It's going to be invisible ones both ways. So the answer, the final answer is going to be KMnO4. You can put the brackets around there. That's not wrong. They usually won't if there's only one of the permanganates. I like the brackets because it reminds me that it's a polyatomic ion, but that is acceptable. CO, CR, O, huh? Okay. CO, what's that? Cobalt. Metal? Yes. Multivalent? Yes, it is. So I know it's ionic. I'm going to write down CO. I don't know which charge is going to go up there. I'm going to have to figure it out. Then I have this Cr2O7. How do I know this is a polyatomic ion? It's got brackets. Cr2O7, it's called dichromate, and it's got a 2 negative. Cr2O7 has a 2 negative. Now, how many cobalts did they put? Oh, there's 3 of them. Yes? Yeah. 3 of these. So, although one of them is 2 negative, what's 3 of them? If one of them is 2 negative, if one of these, what's it called, dichromate? If one dichromate is a 2 negative and I have 3 dichromates, what is the actual charge I'm going to put up here? As a number, I think what I'm saying is it's going to be a 6. 2 negatives 3 times. Yes? You with me? Now, how many cobalts do I have? 2. If I want 2 cobalts, what do I want for a charge so I get a 6? So if each one of these, there's a 2 negative and there's 3 of them. Here, there's 2 cobalts. What charge do I want right here? I think I want a 3. Do I not? That's going to give me a 6 and a 6 in balance. This is a tough one. So, that's the charge. This is going to be Cobalt 3. Can cobalt be a 3? Let me double check. It can be. Whoa, too much. Chromate. Half mark for the cobalt, half mark for the dichromate. If you're missing the Roman numeral or you got the wrong Roman numeral, half mark off. Number 8. Manganese 3 phosphate. Okay. Manganese ionic. Because manganese, it's a metal, yes? Yes, it is. They told me the charge on manganese, abbreviation for manganese is Mg or Mn? Mn. Mn, and they told me the charge on it was 3. Phosphate. Now this is not phosphide. This is not phosphorus. This is phosphate. This is one of the ones from the back of my sheet. I see some of you flipping your sheet over. Yep. Phosphate, right near the bottom. PO4 3 negative. PO4 3 negative. Amber, do my charges balance? Woohoo! So the formula is going to be Mn. I only need one of them because it's going to, when I crisscross, I'm going to get a 3 and a 3, but we reduce it to lowest terms. Instead of 3 and 3, divide by 3, divide by 3, 1 and 1. It's going to be Mn PO4. If you put that in brackets, that's fine, but you don't have to.
Isn't manganese Mg?
Magnesium, and it's cheap, I know. Magnesium is the 12th. Manganese is the 25th. If you made that mistake, I'm glad. Be paranoid. Anytime they use one of those two, make sure you're picking the right one, because I've done that a couple of times too. In fact, I think on one of my answer keys that I made for you, I used the wrong one and somebody caught me on it. Half arc. SF6, S. Sulfur? Metal or not? Not metal. Covalent. Okay. Covalent, now I'm going to use the prefix rules. I'm going to use the prefix rules. Robin, how many sulfurs are there in this particular formula? How many sulfurs are there? The invisible one. And we said if the first compound, the first element, the first atom, if there's only one, you don't put a mono in front of it. So it's going to be sulfur. Oh. It's Canadian and American. Well, it's British and American. You can spell it either way. I probably spell it with an F, with a PH, because I'm a proud Canadian. The same way I spell neighbor with a B-O-U-R and behavior with an I-O-U-R. And I say Z, not Z. But that's me. Robin, how many F's are there? 6. What's the prefix for 6? Hexa. Hexa fluoride. Half mark for the sulfur, spelled PH or F. Half mark for the hexafluoride. In fact, I'm not too fussy on spelling as long as you have a hexa and a fluoride. The last one. Thankfully, I'm old enough, I have carbon dioxide memorized. Some of you might as well. What is carbon dioxide's chemical formula? Say CO2. We actually sometimes call it that. We say, get a CO2 fire extinguisher. So it is CO2, but in case I didn't have it memorized, I would say to myself, covalent. I would have written down carbon. Now, carbon doesn't seem to have a charge, which is unfortunate. I think that's a typo on your periodic table. What's the charge 1 to the right of carbon? What's nitrogen's charge? 3 negative. You know what carbon is? It's 4 negative. Oxygen normally has 2, but what does the di mean? How many oxygens are there? 2? Do my charges balance? Yes, they do. So it is CO2. So even if you didn't get the name, you could find it from there, even if you haven't memorized. How many questions were there? So give yourself a little score, please, out of, count them, 10. And once you've done that, please make certain your name is on it. If you be so, what I want to do is go through here, go through these examples, and then when we get to the homework, I'm going to press pause. I have a sheet for you to practice, some from the textbook. I'm also going to give you a printout so you can see any missing assignments that you've got, because that is going to be homework for the weekend. Then on Monday, we'll go from the toughest, words to a skeleton equation to a balanced formula. Now we're done the unit.
Yeah.
So, to balance an equation, thank you for your enthusiasm, Josh, much appreciated. Candy for you later, way to suck up. To balance an equation, the first thing you have to be able to do is you have to be able to tell how many of each atom there are. And this may sound really, really obvious, but it's not. It's trickier than you realize. So, counting atoms and ions, I wrote here. If I write F2, first of all, what does the letter F stand for on our periodic table? How many fluorides is that? Fluorines, actually, because it's not a compound yet. How many fluorines is that? 2. So let's write down 2 fluorines. We have to be able to read the language of a formula. How many hydrogens and oxygens are there in this next compound? How many hydrogens are there? 2. How many oxygens are there? I'll put a 1-O because I'm worried if I write a 1-0 later on, I'll think it's a 10, right? Okay, now it gets trickier. How many phosphoruses are in this particular ion? Wait a minute, I only see a 1 next to the letter P. How do you get into 2? You're right. How? Okay, who's in Math 10 right now? Okay, I know Mr. Rocca and myself, we're just in the middle of doing polynomials. A lot of the stuff with distribution and coefficients, this is one of the areas it's used. A lot of the math for polynomials fits in with what we're doing here for formulas. So you need to realize there is 2 phosphoruses. Okay, how many oxygen atoms are there grand total? Miller, you with me? Okay, or am I going to move you? Good. How many oxygen atoms are there? 8 oxygen atoms. This next one is about as tough as it gets. We're going to break it down into steps. First of all, what this 3 is on, it's on everything. In math, we put brackets around stuff. In chemistry, we don't. So when they put a 3 in front of a compound, they're saying triple everything inside there. Or one way to think about it is this. 3 molecules of Ca3PO42. That's what that 3 means. Or if we want to break it down further, how many atoms of Ca, of calcium, are there in this particular element, in this particular molecule? What? 9? Or are you a German saying no? 9? Yeah. I'll never get tired of that joke. Yeah, 9 atoms of calcium. See it? 3 and 3. 3 times 3. How many ions of PO4 negative? Well, there's 2 to begin with, but we're tripling everything. How many ions of PO4 negative? 6. Or if you really want to break it down, Brad, into its fundamental, going element by element by element by element, 9 atoms of calcium. How many atoms of phosphorus grand total? Well, let's see. 2, triple that. 6 atoms of phosphorus grand total. What about oxygen? 8. See it? Triple that. 24. Mr. Dewick, are they all going to be that tough? No, they're not all going to be that tough. That is fair game, though, as like the nasty question, the last question, the toughest question. So let's balance some equations. This is a strategy I stole from another teacher, but I think it works fairly well. So it says, steps to balance equations. Now, some of the easier ones, you'll be able to skip some of these steps, Amy, and you'll start to just see the answer in your head. And that's great. But in our notes, we'll start writing out these steps, so if it works for the easier ones that we can do in our head, it'll also work for the yuckier ones that we can't. So we're going to be very meticulous for the first little while here. Eventually, Curtis, you'll start taking shortcuts. Knock yourself out as long as you're still getting it right by checking the answers. Okay? So here is our skeleton equation. Magnesium combined with some oxygen forms magnesium oxide. But this is not balanced. We're going to have to put coefficients in front. Step 1, it says, determine the number of atoms for each element. Over on the left-hand side here, how many magnesiums are there? 1. How many oxygens are there? 2. See it? Over on the right-hand side, how many magnesiums are there? 1. How many oxygens are there? 1. Are we balanced? Zoom out right now and move your eyes across. If the numbers all match, we are balanced. We are not. Step 2, pick an element that's not equal on both sides of the equation. Oxygen. Add a coefficient in front of the formula with that element and adjust your counts. How many oxygens do I have here on the left? How many do I have here on the right? How many would I like to have on the right? So I can do that by putting a 2 there. But what else just changed? Magnesiums. This went from being a 1 to being a 2. See it, Kenzie? Are we in balance? We are for oxygens, but are we in balance for everything? How many magnesiums do I have on the left? How many do I have on the right now? Are we in balance? No. No, the numbers have to match. Numbers have to match. We're not in balance. Okay? Oh. 2 of those. Thank you. I forgot to adjust that count. Are my oxygens in balance then, Ty? Yep. Are my magnesiums? Nope. Well, let's go walking off to the left-hand side. I have 2 magnesiums on the right. How many do I have on the left, Ty? 1. How many would I like? 2. Let's try putting a 2 in front of the magnesium right here. Now that's going to change that to a 2. Is that going to change the number of oxygens? No, because it's separate. Now we zoom out. Am I in balance? Let's see. How many magnesiums do I have, Ty, on the left-hand side?
2.
How many on the right-hand side?
2.
How many oxygens do I have?
2.
How many on the right-hand side?
2.
Am I in balance?
No.
What's out of balance?
It's not in balance.
No, am I balanced? Am I in balance? Sorry, you misunderstood me. Am I in balance? Yes. Am I unbalanced? No. This is good. My bad. I'll drop the in. Am I balanced? Yes. Okay. Let's try another one. A little tougher. Calcium plus O2, dioxygen, gives you calcium oxide. Step 1, list how many of each atom there is really quickly. So, over on the left, how many calciums are there, Amber? 1. How many oxygens? Careful. 2. Over on the right, how many calciums are there, Amber?
1.
How many oxygens?
1.
Am I balanced? No. Okay, suggestions. Put a 2 in front of it. Okay, so someone said, hey, Mr. Duick, put a 2 right there. Now that's going to change the number of calciums and the number of oxygens, right? Am I balanced? Well, oxygen is calcium. Nope. Now what? Put a 2 there, and that makes that 2. Are we balanced? In fact, that was almost the same chemical ratio as the previous one. Let's do some that are a little nastier. Turn the page. All right, Mr. Duick, here we go. Dinitrogen plus dihydrogen gives NH3. Oh, that's ammonium, isn't it? I think that was ammonium from the back of the polyatomic sheet. Okay. Let's try this out. Laura, how many nitrogens on the left-hand side, kiddo?
2.
2. How many hydrogens?
2.
How many nitrogens on the right-hand side?
1.
How many hydrogens? 3. Are we balanced? Now, here's a hint for you, and I don't see this in a textbook, but this is what I found when I did these. Start with the uglier one first, the one that's going to be tougher to balance. If you start with that one first and you get it right, often the easier one will have been balanced along the way. In other words, what's going to be easier, turning a 2 into a 1 or turning a 2 and a 3 into something else? I think the hydrogen's going to be uglier, is going to be tougher. I'm going to start with it. So, I got 2 on the left, I got 3 on the right. How many do I really want? What number do those both go into? Or for those of you who are in math, what's the least common multiple? 6? So you're suggesting putting, correct me if I'm wrong, a 3 there? That would give me 6, I agree. And a 3 right here? A 2 right here. Ah! And that would give me 6, but that would also give me 2. Oh! Oh! Are we balanced? Yeah. Start with the uglier one, and if you do that, often the nicer, cleaner one will just trickle down into place. It's not wrong to start with nitrogen and balance it, but I'm just from doing these. Do you understand what I mean by the uglier one? The one that it's obvious you have to change both sides on. Start with those first. All right. Cu2O, copper oxide plus carbon gives copper plus carbon dioxide. Okay. How many coppers are on the left-hand side? Mackenzie. On the left. 2. How many O's? Yeah. How many oxygens on the left? 1. How many carbons on the left right now? 1. How many coppers on the right-hand side? 1. How many carbons? 1. Oh, this is going to be easy. How many oxygens? Ooh. Oh, hang on. 2. 1, Mr. Duick. Duh. Erase it and do it properly. You have e-ink for a reason so that no one can tell that you make mistakes. Granted, all your kids know. Mackenzie, are we balanced? No. I'm looking at this. I think doing copper or oxygen are both going to be about the same level of difficulty. So pick. Which one do you want to balance? Copper? Okay. How would I balance copper? What would I try? Folks, what would I try? Yeah. Is that a hand up or a twit? No? Yeah. I'd try that first. And it is, by the way, until you get really good, balancing equations is kind of a guess and check method. I totally agree. I'd try putting a 2 right there. That would give me 2 of those. Am I balanced? Well, I am for copper, I am for carbon, but I'm not balanced yet. Yeah?
You can put copper oxide as 2.
I can put copper oxide as 2 up here. Now that's going to give me 4 of those and 2 of those. What? Double this one, which is going to give me 4. Am I going to write a 2 times 2 in front, though? What am I going to write instead? Mr. Duck?
Yes.
Would I be smart if I did these in pencil? Yes! Because you're going to be guessing and checking and making lots of changes. If you're someone who's a pen freak, get over it. Do these in pencil. Okay. Balancing equations. Step 1. On Monday, we're going to try picking up from here where it says going from the word equation to a balanced equation. Carbon, this is tougher. Because you got to go from this to this without the coefficients to the balanced equation. It's 3 steps. And there's just no way around it. It's tough. Meanwhile, can you all open your books, please, to page 207? Page 207. Oh, books. Practice. Learning. Shut up. Forgot your book? Look on someone else's. I'm also going to be giving you a worksheet. You can work on that. Okay. Page 207, number 1, at the very, very bottom. Actually, what I should have written is page 207, numbers, scribble, 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 1 to 4. Check your answers on page 591. So all it wants you to do is list the total number of types of each atom. That's page 207. Turn to page 211. Okay? Page 211 is pretty challenging. I would save page 211 until after I've done the sheet that I'm about to hand out called Balancing Equations Practice. The sheet that I'm giving you, it does have the answers on the same page or on the back. I think I put it on the same page, as a matter of fact, so you can check your answers. There's an art and a science to balancing equations. I've given you the science. The art is, as you practice, your brain, Leah, will just suddenly start to see stuff. And there's no way to get there without practicing. Having said that, if you finish it all in class, you got no homework for the weekend, and you're getting a full half hour, let me hand out the sheet.